All right, so in this one, we're going to talk a bunch about numbers and percents and perhaps ratios and just some problems. There's a lot you can do with it, but some of them can be quick as well. So, okay, so in like the general sense of how numbers are classified, there's natural. Yeah, I'm gonna actually just do this. Natural numbers, which are like 0, 1, like onwards. These don't include like negative numbers. I think it was like naturally you start to learn like 0 onwards. Yeah, and integers obviously. Uh, okay. This is for like integers usually, which is like -1, 0, 1, like so on both sides basically. Yeah, it could be negative or positive. Rational, it could be, I don't know, rational, I suppose. These are numbers like that can be basically written as a fraction, if that makes sense. So 1.333 repeating is a rational number. -7 is 11, 5 is 19, square root of 64, and stuff like that. I don't know. Those are pretty much all rational. Real numbers, square root of 22, 22 as well, for that matter. These are all real, which a lot of numbers are. Yeah, that's usually it's supposed to be like this. There's another section. Real numbers. E is a real number. Pi is a real number. These numbers are irrational, but they're still real. Yeah. So the real numbers can include irrational numbers. That's fine. Then there's like complex numbers, which is different. Which is like I mainly, which is a square root of -1, obviously, but we don't have to worry too much about that. So let's do a really quick practice of like a bunch of numbers, like classifications, if that makes sense. 0.555. Rational or irrational? Rational. There's nothing special, it's just rational. -2 pi, irrational. 9.0, rational. -11 pi, irrational. 6.5, rational. -3 plus pi, irrational. Plus pi is irrational. Square root of 64, rational. Just 8 is irrational. Square root of 3 squared. Well, square root of squared is that number, and square root of 9 is also 3, which is also rational, so it's rational. 3 to the 3.14. Rational. No, this is not pi. Pi goes on forever and doesn't repeat, which is rational. This is fine. Rational number raised to rational, it's going to be rational. We can't get irrational things out of nowhere. 0.02 times 1/3. This is going to be irrational because this can be written as a fraction. This is already a fraction, and if you multiply two fractions, it's essentially going to be a fraction. Yeah, 1/3 is like rational. Like you can write it as a fraction because it's 1/3. Yeah, so this is really quick intro with that. Percents, they just mean out of 100. You've seen like, pretty much 100%. You know what that means usually by now. I'll start with this. Suppose it's 40 and I don't know, it's like 40 cookies or something. And there's a 15% more increase in cookies next year or something. How many cookies are there this year? So it's a 15% increase. It is essentially saying you have 115% of the original value because you already have all the original and there's an increase by 15%. So it's this, like 115% increase essentially. So the way you do that is you write that, there's two ways to do it. There's one like simpler, like basic, like one calculation way, which is just have like add up the total percent value of the original, which is 115% because there's an original 100%, and you're adding 15. So this will be then 1.15 when you convert to a decimal, which you need to, and then you multiply that by 40. So you get 46, I believe. Around there, yeah. Or you could just do 15% of 40. So the way you calculate stuff like this, 15% of 40. 15% you have to convert to a decimal, 0.515. All becomes times as a multiplication. You leave the second part. So this is like 6 or something, and then you just add that to the original value, which should also give you the answer. All right. That's basically the essence of percents. We'll do a little bit more. Let me just talk about ratios real quick. Ratios are just like, honestly, really all fractions technically can be considered the ratios because like 2/3. If that's the ratio, that means like if you have 4, what would be the bottom number? If you want to maintain the same ratio, well, if you multiply this by 2, you have to multiply that by 2, so it should be 6. Yeah, so that's like kind of the same idea. So if you have 1 mapped to like 28 in a sense, 3 mapped to some number, and some number mapped to 140. So since you have one full thing, the pattern is actually it's a little bit ambiguous what the pattern really is, but I'm just gonna tell you the pattern is times 28 instead of adding like 27 or something. I'm telling you what the ratio is, the common ratio, whatever. So you just multiply this by 28, and then you get a number, which is what, 28 times 3 is going to be 84, and it's still 28. So now you do the other way, you do 140 divided by 28 because of the inverse operation, you get 5. Yeah, and basically you want to maintain the same ratio in a sense, if that makes sense. Rates are a little bit kind of different. So suppose someone buys 4 cookies. Oh boy. For $272. Don't worry about the outrageousness of that. Maybe they're really good cookies. What's the cost of 1 cookie? That's kind of a rate, because like how much does 1 cookie cost? So if you can use that to find out how many, like 20 cookies would cost or something. That's a rate. It can help you see how, like frequency, I guess, against some like quantity of measure in a sense. Okay, well in this case it's just 274 divided by 4 cookies, which will give you about $60 per cookie. That's the rate, because it's per cookie. You have 2 quantities, money and quantity. Yeah. Okay. Same thing with and like I don't know, like if you have 644 cookies you eat in like 7 hours, how many can you eat in 9 hours? That's a kind of a ratio problem. You want to find x, and there's an equal sign because the ratios are similar, aka the same. So this you could do again. You could do cost multiplication if you want. 7x is going to be 9 times 644, which I will just tell you. It's a big number, I believe. Well, kind of. 5796, and you divide by 7, divide by 7. And you're going to get 828. That's how many cookies you need in 9 hours. Using the same rate, I guess. Does that make sense? Okay, the other ones, like problems like this again, like the percent problem. So what is 70% of 20? We'll convert that to decimal times 20. So you can have 0.7, which is the decimal form of 70%. Multiply that by 20, you get your answer to be, I believe it's 14. Yes, 14. Yep. And you just keep doing problems like that. 90%, if you want to do 90, this was 0.90. And that will be, so 0.90 times 20 will be 18. That is not 18, that's 10, but 18 is 90% of 20. Yeah, so those are pretty much how you would do it. Let's do quick math. 10 problems related in percents, and we'll be done for this. 450% of 10. 450% of 10. 450% is going to be 4.5 because you move the decimal 2 places, times 10. So that's just 45. All right. 950% of 100. It's going to be 9.5 times 100, which is 950, I believe. You just times by 100. You just move, since it's tens and stuff like that, everything is based on 10. You can just move the decimal places around. That'll be the quickest thing. 1% of 10, I guess you could say. 1% is 0.01. How can you check? Just move it 2 places, you get 1%. So we're going to be doing 0.01 times, so it was 1% of 10, right? So 0.01 times 10, which is 0.1. Yep. 0% of 100. I wouldn't think about that or do it in math. Like if you want to do math, this will be 0.00 times 100, which is an outrageous way to do stuff, which is 0. 0% of anything. There's nothing. 100% of 10. Well, that's everything of 10, so just 10. And then mathematically, just move it there. 1 times 10 is 10. Yeah. Okay. 10% of 10. That's actually, like, one way to think about it is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10%. These are all like we can do 10, so just 1, which is like 10%. If that makes sense, because like 10% is 0.1, and you're doing 0.1, so a tenth of 10, which is just like 1% in a sense. When I said 10%, I meant like 10 cents, not like 100. So it is 1/10 in a sense. So in essence, the answer is this: 10% of 10, right? Which is 0.1 times 10, which is just 1. Yeah, that's what I meant. Like when I had 10 of them, I had like one of them was 10. Yeah. So the answer is 1. Show up on that. 0.01% of 1. So that's 1, 2. 0.001 times 1, which is just 0.001. That's your answer. 1,000% of 1. Yeah, 1,000% of 1. So 1, 2. So that's 10 times 1, right? Because like 1, that becomes a 10. Yep, that's just 10. Don't get scared by these. These are just think logically. So 1. What about 1? What is this number? 10,000% of 10,000. 4 zeros. Yes. So 1, 2. That's 100 times 4 zeros. So 4 zeros plus 2 zeros is 6 zeros. So it's essentially 1, 2, 3, 4, 5, 6, 3, 3. Yep, that's your answer. 6 zeros. Okay, what is 1, 2, 3, 4? 2, 2, 4, 2, 1, 5. 1, 6, 5%, whatever that big number is, of 0. Okay, again, don't need to think. Don't need to think, but if you want to do it mathematically, it's this thing times 0, which is averages again, it's 0. Like any percent, like 0. There's nothing there, so 0. So yeah, those are some quick math on percents, and that will be it for now. Thank you.